No. So with an inequality, if we multiply by a negative, it would have to flip our inequality. If I try to multiply by x plus 5, do we have any way of knowing if x plus 5 is positive or negative? No. So that's not going to work. Now we could think about all the stuff we know about graphing these. This isn't going to be how we solve them, but I could use the graph to kind of illustrate this. We know this has a vertical asymptote where? Mm-hmm. Okay, where's the horizontal asymptote? Same degree on top and bottom, so it'd be at 1. X-intercept, if you put in 0 for your y, so that's when the top is 0, that's at? That's the y-intercept when x is 0.
Oh, negative 3.
Mm-hmm. Positive 3. If you put the top equal to 0. Okay, and then we could use our graphing calculator and we would see, maybe something like this for our graph. So if you're looking at the graph, can you tell me where this thing is greater than 0? Yeah, it was greater than 0 over here and after 3. So that those places where it changes from positive to negative, those are either at your x-intercepts, which is when the top of our fraction is 0, or it's at our vertical asymptote, because we have breaks in our graph. So we could draw the whole graph and use it, or we can do what's called a sign line. We don't need the entire picture. We just need to know if it's positive or negative. And the places where it changes are when the top and the bottom are 0. So if we set the top equal to 0, that's our x-intercept, that's 3. If we set the bottom equal to 0, that's our vertical asymptote, which is negative 5. So then our sign line says we just really need to know, is it positive or negative between these numbers? So the easiest way to do that is just pick some test points. And what's a number smaller than negative 5?
Negative 6.
Something in between negative 5 and 3.
4.
And
Negative 4.
how about, let's just do 0, and then 4 could be our number bigger than 3. And we're going to put those numbers into this fraction. And I don't even care what the answer is, just if it's positive or negative. So if I put in a negative 6, the top will be negative, the bottom will be negative. A negative divided by a negative is
Positive.
If I put in a 0, the top is negative, the bottom is positive, negative divided by positive.
Negative.
If I put in a 4, 4 minus 3 is positive, 4 plus 5 is positive, positive over positive is positive. Okay, is that the same thing I got by drawing the graph? Yeah, but probably a little bit faster because I didn't have to go through vertical asymptote, horizontal asymptote, intercepts, all the things. So we want to know when this is greater than 0 means positive, so it's these pieces. It's not equal to 0, so everything gets a parenthesis, so negative infinity to negative 5, union 3, positive infinity. So you have two options for these. You can either graph it, like we did the last chapter, or we make the sign line, realizing that the only places we can change from positive to negative are the vertical asymptotes and the x-intercepts. So when the top and bottom of our fraction are 0. Questions there? Let's look at this one. What's different about this one? It's not a 0. All right, so if we're going to be able to do this, we have to have a 0 over there. So the first thing we're going to do is subtract over that 1. Okay, now I really need a single fraction. When we were graphing those, we had a fraction, and then we were looking at all the properties of the graphs. So I need to put those together. If you want to add or subtract fractions, what do you have to have? Common denominator. This is like 1 over 1. So if I want it to match, it needs to be over x plus 4. So we're essentially going to multiply the top and bottom by x plus 4. So to put them together, you would have to distribute your negative. So 5 plus negative 4 is 1 minus x. X plus 4 greater than or equal to 0. Right, so at this point we have two options. We can either go through the whole process of graphing or do what? Sine line. Sine line is what makes the top and the bottom of this fraction equal 0. Your x-intercept and your vertical asymptote. So we get 1 and negative 4. So a number smaller than negative 4 in between negative 4 and 1 and bigger than 1. And we are going to take those numbers and plug them into this fraction to decide if it's positive or negative. So 1 minus negative 5 would be positive. Negative 5 plus 4 is negative, so that section is negative. 1 minus 0 is positive. 0 plus 4 is positive, so that section is positive. 1 minus 2 is negative. 2 plus 4 is positive, so that section is negative. Both of our examples, our signs have alternated, positive, negative, positive, or vice versa. That's typically how it happens, but not always. You could get the same sign twice in a row, so don't just assume that it has to be the opposite one. All right, now we ask ourselves, do we want positives or negatives?
Positive.
Greater than is positive. Equal to means brackets. However, what is the one number x can't be? Negative 4, like we talked about yesterday. The bottom of a fraction can't be 0. That's a vertical asymptote. So equal to means bracket, but the negative 4, because it's on the denominator, it gets a parenthesis no matter what. So it's negative 4 to 1. The 1 gets a bracket, the 4 does not. Is that okay? Let's try another one. Where do we begin? Right. We have to have 0 on one side. So first step will be to bring over that 4 and get what? So we have 3x plus 1 over 2x minus 3. Subtract over the 4, that's like a 4 over 1. And then we have our 0 on the right. If we want to put these together, we have to have a common denominator. So we're going to multiply top and bottom by 2x minus 3. So we need to distribute our negative. 3x plus negative 8x is negative 5x. 1 plus 12 gives me 13. So now we're set up to the point where we can solve our problem because we have a single fraction on one side and 0 on the other. That's our goal. What do we have to do next? We have to figure out what makes the top and bottom 0, essentially your x-intercept and your vertical asymptote. So, do we have to worry about if things will get parentheses or brackets on this one? No, there's no equal to. Everything will get a parenthesis no matter what. So top equal to 0, bottom equal to 0. All right, test points. Smaller than 3 halves, so maybe a 0. In between 3 halves and 13 fifths, so maybe a 2. Bigger than 13 fifths, maybe 3. And we're taking those numbers, putting them into this fraction to decide positive or negative. So if we put in 0, we get positive over a negative, which is negative. Put in a 2, and we get a positive over a positive, so that's positive. Put in a 3, we get a negative over a positive, which is negative. Which answers did we want?
Negative.
Less than means the negatives. So we have 2 separate pieces. Negative infinity to 3 halves, union 13 fifths to positive infinity. Let's do another one together, and then I will have you guys try the problem. What's the first step? Gotta get the 0 over there. So we would have 7 over x plus 2 minus 1 over x plus 2 greater than or equal to 0. Do we have to get a common denominator? No, we already have it. So 7 minus 1 is just 6 over x plus 2 greater than or equal to 0. All right, top and bottom equal to 0. Does 6 ever equal 0? Nope. And then if you set x plus 2 equal to 0, we get negative 2. So the only number I have to put on my number line is negative 2. So test points, smaller than negative 2, bigger than negative 2. Well, we put those into this fraction. So the top is positive no matter what. Negative 3 plus 2 is negative, so this section is negative. Put in a 0, so we have positive over positive, which is positive. Which ones did we want? Positives. Okay, equal to means bracket. Can I put a bracket on the negative 2? No, because it's the vertical asymptote. It's what makes the denominator 0. So it is just negative 2 to infinity. Here's your problem. So that's like a 4 over 1. Have to get a common denominator, so you multiply it by x minus 3 on top and bottom. since I'm subtracting, I need to distribute that negative. Plus 12. Right, so we get negative 4x plus 18 over x minus 3 greater than or equal to 0. Do we agree with that part? Top and bottom equal to 0. So we get 9 halves and positive 3. So when you put them on your number line, make sure you do it in order. 3 is smaller, so it goes first. Smaller than 3, in between, and bigger. We plug them into this fraction just to decide positive or negative. So if we put in 0, we would have a positive on top and negative on the bottom. So that's negative. Put in 4, we get a positive on top, positive on the bottom, so that's positive. Put in 5, we get a negative on top, positive on the bottom, so that's negative. Which ones did we want? Positives, greater than is positive. Okay, equal to means bracket. Which one can have the bracket? The 9 halves can, the 3 cannot because it came from the denominator. So it's everything between 3 and 9 halves. Any questions? Let's do one last example. Final one for the day. So if we subtract, we need a common denominator. What do we have to do? So the first one needs x minus 3 on top and bottom. And the second one needs x plus 1 on top and bottom. And I'm not going to multiply out the bottom, I'm going to leave it factored. So if we subtract it off, that gives me a 2x minus 14 over x plus 1, x minus 3. How, if I have two things on the bottom, what does that mean about the graph? Two vertical asymptotes. So we can change signs more often. This graph has more breaks. So now we find all those points for the number lines. So we set top and bottom equal to 0. So for the top we get 7. For the bottom we have to do each of these parentheses. So we have a negative 1, 3, and 7. Numbers smaller than negative 1. In between negative 1 and 3. Bigger than 3. Or sorry, in between 3 and 7. So 4, 5, and then bigger than 7, maybe an 8. So we're putting those in here. So if I put in negative 2, the top is negative. Negative 2 plus 1 is negative. Negative 2 minus 3 is negative. If you have 3 negatives, your answer is?
Positive. Oh, wait, what?
2 negatives make a positive. 3 would turn it negative again.
I was talking about just the.
Yeah, the bottom would turn out to be positive. And then if we we put in a 0, the top is negative. 0 plus 1 is positive. 0 minus 3 is negative. So this one would turn out to be.
Positive.
We put in a 4. 2 times 4 minus 14 is still negative. 4 plus 1 is positive. 4 minus 3 is positive. So that section is. If we put in an 8. 2 times 8 minus 14, that's positive. 8 plus 1 is positive. 8 minus 3 is positive. So that is positive. We wanted less than. So that is the negatives. No equal to's. So it would be negative infinity to negative 1. Union 3 to 7. How are you guys feeling about this? So I want to give you time to practice it now so you can ask questions. There's a Math Excel assignment open.